The HiProvision software allows us to quickly and easily create, configure, and deploy MPLS-TP tunnels and services. These tunnels and services ensure the Dragon PTN nodes are able to reserve and allocate guaranteed bandwidth for needed critical endpoint devices and data flows between them. Once our Dragon PTN nodes have been discovered, we can go to the connection configuration page to view any existing tunnels and services and create new tunnels and services. Typically, this process would be very difficult and resource intensive over a command line interface. With HiProvision, we would simply click the Create Tunnel page, give our new tunnel a name, and choose what kind of topology that we want to use. In our case, we'll do a simple point-to-point. We're also going to select protection so we have a redundancy on this tunnel. We'll simply click our source and destination nodes. We'll then select our primary link. In this case, we'll select the link that's directly connecting both of these nodes, XT2210 to XT1104B. We'll also select our protection or backup link. In the event of a failure between the direct link between XT2210 and XT1104B, we'll have our data flow pass through XT1104A, the node on the bottom. We have some options to change our wait to restore time. We have options to change the interval of watchdog frames, and we also have the ability to be revertive. In this case, if the primary link fails and later comes back, we will force traffic to go back to the primary link. All label switches for both forward and reverse are automatically generated. This is typically knowledge that has to be manually generated and manually configured to MPLS-TP node devices with other manufacturers. Our HiProvision software automatically allocates this and applies it to not only the nodes that we have as our source and destination, but also our nodes that are acting as alternate sources or alternate links. We get a logical diagram that shows our primary and backup paths in a lighter shade. Once our tunnel is created, we can create services which allow data flow to pass through the tunnel created. We give our service a name, and we can pick from specified service types: Ethernet, serial Ethernet, circuit emulation, and voice data. In our example, we'll just use standard Ethernet. We also have the option of doing a port or VLAN based approach if we wanted to limit certain VLANs to pass over this service type. We'll pick our source, and we can pick a certain port on our source Dragon PTN device. We also have the option of clicking a list on the left or on the depiction of the PTN chassis in our diagram on the right. We'll do the same for our endpoint. And we have the option of specifying whether we're going to keep, untag, or replace the tag if we are dealing with VLANs. In our case, we'll just keep tags on. Then we match our tunnel to our service. We'll select our test tunnel. And then we can select some quality of service parameters. We can give it a certain priority if there's other services already using this tunnel. And we can give it the maximum and minimum bytes per second on speed and burst rate. So if this is particularly chatty traffic, we can make sure that the tunnel and service is able to have enough reserved bandwidth. We get our useful bandwidth rate, which is the maximum that we would get minus the overhead needed to keep this service alive. all of the pseudo-wire forward and reverse label switching and LSP ID information is automatically applied to our service. Again, this is something that is very difficult to do with a manual approach. HiProvision does all this automatically. Once our service has been applied to the tunnel, we could see that our connection diagram page has updated. We could see that percentages between our nodes have changed to reflect the new service applied to the tunnel. We can click on this percentage to see all of our services on the connection view. We could see that this is a 1 gigabit link, of which 833.98 megabits is usable and 195 is currently reserved. We can see all of our reserved bandwidth allocations, the DCN, which is our watchdog frame protocol, an existing Ethernet and MRP service and tunnel, and the test service that we just created. We could see that 50 megabits was reserved between XT2210 and XT1104B. We can also click our different tunnels to see that the links also reflect our created services. All of this is automatically managed and preserved by the HiProvision service. In just a couple of minutes, the Dragon PTN with HiProvision software allowed us to create and provision MPLS-TP services and tunnels, a process that would typically take hours, if not days, to complete with competing hardware.